Alright, welcome back everyone to the live stream. Hopefully you're hearing me well. Wait, let me try this. I've got a wrong microphone. Ay. Settings, audio. Alright, let me see if that's better. Aeon here. Hello there, my man. How are you? I'm pretty good. I'm just trying to figure out some stuff. Just 1 second. Alright. Alright, let me just try to listen to the live stream. I think I fixed the audio, but you already got your new Mac, right? Yep, check this out. There you go. It's just hard to get used to it in the beginning, I guess. Let me see if the audio is alright on the stream. Nice, yep. Go to YouTube. Right now, at least, look at this. You remember last stream how I was unable to show you what is on my iPhone? Yeah, I'm probably not going to be able to show you as well, but wait, there you go. I don't know if you see that, but then I can go to the stream. If you see that, but then I can should be alright. Yeah, you can indeed. I can now show you what's on my phone. Alright, perfect. So I still haven't set up most of it. It's still kind of hard for me to navigate, but we'll get used to it. And I have a little chat that just closes whenever I click on something else. I cannot show you because it's on my second monitor, but whenever I click to read the lesson from the Odin project, the chat closes. So I'll maybe do it the old way of just I'll close down this chat and I'll open it in Safari. So YouTube. Okay. We'll do it the old-fashioned way. I haven't put in the sub counter like anything. No. See, now for example, I cannot open the there you go. I was just going to say I cannot open the page on my other monitor, but there we go. Alright, I think we're finally ready to start. Today I don't know how long it's going to be because I don't have much time, but we'll see how far it goes. We're doing factory functions and the module pattern, which I have no idea what all of this means, so we'll check it out together. They're saying we have discussed object constructors in the previous lesson. Yep, I remember that. However, there are some of the many ways to organize your code. While they are fairly common and fundamental building block of the JavaScript language, they have their flaws. So this lesson contains Describing the scope of a variable. Explore what closures are. Briefly consider the disadvantages of using constructors. Discuss factory functions with examples. Discuss private variables and functions concerning factory functions. Showcase object inheritance with the help of factory functions. Describe what module pattern and IIFEs are. Discuss the encapsulation and how the module pattern helps with namescaping. So a lot of stuff, and I don't understand like half of it, or like most of it. I have no idea. So starting with the scoopfuls of scoops. The word scooping essentially asks where is a certain variable available to me. It indicates the current context of a variable when a variable is not declared with any functions existing outside any curly braces. They are said to be in the global scope, meaning that they are available everywhere. If they are within a function or curly braces, they are known to be locally scoped, which makes sense. Alright. Before ECMAScript 6, JavaScript had a single keyword to declare a variable, var. These variables can be redefined and updated, others set to be defined within the function scope, meaning they're only available within the function they are declared in. In ECMAScript 6, the words let and const were introduced, while var variables were function scoped. These allow you to define variables that are block scoped, basically scoping the variable to only be available within the closest set of curly braces in which it was defined. These braces can be those of a for loop, if-else condition, or any other similar construct and are called a block. Let's see an example. So we already, I feel like know this, but let's see. They're saying let h, and this is a global variable because it's not within any like curly braces. This is a function, and hey, a curly brace indicating a block. So this whole print h is one block. And we have var h34. This is a function scoped variable, so within that function is the scope of this var h, and we can use it only inside the function. So if this is yet another curly braces, there's a block, so this if is a block. This is a block scoped variable that exists within its nearest enclosing block, the ifs block. So const is only available in here. Error, we tried to access a block scoped variable with not within its scope. So as you can see, we're trying to access const h, and its scope is within the curly braces, so we get an error. Print global h. It's a global variable, so we can do that, and again console log var h, we get an error. Alright, sure. I think this is known already. Take a look to brew on that example. In the end, it's not some mind-blowing concept, but there is a whole bunch of terms in there. It's all help us understand the next mammoth closures. Closures aren't scary. The best way to approach this would be to start with an example. Take a look at this piece of code below. So we're having a function make adding with the first number. First is scoped within the make adding function. Const first, so we have equals first number. And then we have return function resulting second number, which is second is scoped within the resulting function. Alright, const second number, return first plus second, we can do that. But we've not seen an example of a function being returned thus far. How do we use it? Const add 5, make adding, so they're accessing this function. First number is 5. And console log add 5, 2, so it will call this console walk. Wait, wait, then second number, we don't have a second number, so add 5 is make adding. All right, we have a first number, but then when we call like console walk with add 5, it goes in here and add 5 takes this as a second number. I'm kind of confused at how this works, but let's break it down. The make adding functions. Hey fam, Supreme Overworld, welcome to the stream, my brother. How are you doing? Long time no seen. Let me see if the Discord works. Just 1 second. I just want to see if this command works. I don't think I have Discord installed, but let me quickly open it. Yep, the invite is invalid, so that's kind of a bummer. I'll have to quickly fix that. But let's just read about this one more time. So the make adding function takes an argument first number, okay, declares a constant first with the value of first number and returns another function. So it will return another function. When an argument is passed to the return function, which we have assigned add 5, it returns the result of adding up the number passed earlier to the number passed now. So first, second, all right. This makes sense. Right, I want to configure the Nightbot to give me the right invite for the server, because set this link to never expire and no limit, expire after never. Temporary members. All right. Copy. Alright, so that makes sense now that it works when you kind of return that second function. YouTube. Alright. Let me edit the command. Everyone edit the link. There you go, update. So now it should be another link when you type in the Discord. I wonder if the one in my profile does work as well. Nope, it doesn't work. What a bummer, man. Probably some people tried to access the Discord via my link in bio and I didn't let them because I'm a moron. I feel bad for this. Alright. So now it's giving a different link and yep, you can finally access it. Shit. Alright, that's better. Sorry for that. We'll keep going. What do we have next? Now, while it may sound good at first glance, you may already be raising your eyebrows at the second statement. As we've learned, the first variable is scope within make adding function. When we declare the use of add 5, however, we're outside the make adding function. Make adding, we're inside the make adding. how does first variable still exist, ready to be added when we pass an argument to the add5 functions? This is where we encounter the concept of closures. Functions in JavaScript form closures. A closure refers to the combination of a function and the surrounding state in which the function was declared. This surrounding state, also called its lexical environment, consists of any local variables that were in the scope at the time of the closure was made. Here, add5 is a reference to the resulting function. Add5 is a reference to the resulting function. Add5. Alright. Which contains the first variable, making it available to use. They say this is a crucial behavior of functions, allowing us to associate data with functions and manipulate that data anywhere outside of the enclosing function. If you're still confused, read the MDN documentation on closures, and we may have to, but only the sections lexical scoping, closure, and practical closures. So, lexical scoping, closure, and practical closure. So these three. Alright, sure. So what's wrong with constructors? Alright, before we see what's wrong with the constructors, let's just go through these three because I'm not fully sure I'm getting them. And how do you open up developer tools on Safari? Maybe I'll have to install Chrome, do you know? I think I'll have to install Chrome because in the Odin project they told us to use Chrome and use these developer tools for Safari. I don't know what kind of developer tools they have, if they have one. So for this stream I'll keep it to Safari, and from next on, yes, most people use Chrome even on macOS. Indeed, on my phone I'm used to Safari, but and actually you cannot install Chrome on macOS. It's just a skinned version of Safari. So on your phone you're always getting Safari, but for the Mac I think yeah, I'll install Chrome. Alright, let's see. Closures. Do you guys know this actually? Before joining the stream, did you know about closures? A closure is a combination of a function bundled together and closed with references to its surrounding state or lexical environment. In other words, a closure gives a function access to its outer scope. In JavaScript, closures are created every time a function is created at function creation time. Oh, didn't know that. How does that work? I'm not sure, but there was a lesson in the Odin project where they told us, even if you download whatever browser you want, like Firefox, Safari, so on and so forth, on your iPhone, it still, in the backend, it's still Safari. It's just a skinned version of Safari. So, yeah, you cannot get any other browser on your iPhone. Lexical scoping. So consider the following example code. You're the main boss and we're looking up to you. I started learning functions today. For sure I'm not. For sure I'm not, but we'll learn together. It's good that you start functions already. Nice. That must be exciting. And you already watched the stream, so you know a little bit how they work. Alright, so they say function init, which I think it's initialized, but we'll see. Var name Muzio, this is a local variable created by the init, so local variable. Function display name, Display name is the inner function that forms a closure. Console walk name. Use a variable declared in the parent function. But you can use variables declared in the parent function, can't you? I still don't get why this is a thing, but we'll see. Init creates a local variable called name and a function called display name. Alright, it does, right? The display name function is an inner function that is defined inside init, and it's available only within the body of the init function. Note that the display name function has no local variables on its own. However, since inner functions have access to the variables of outer scopes, display name can access the variable name declared in the parent function init, right? So this is pretty straightforward. I think this is like known already. Run the code using this jfido link. Let's run the code, and what happens? I have to open developer tools. I have to open the console, and I don't know how. Can you actually do that? Can you open dev console in Safari? First enable developer menu. Alright, we'll go through it later. I don't want to bore you with that, but for the next stream I'll be ready. I'll have my sub count as well. It's like setting this thing up was a pain in the butt, but you know what? I'll have to do it a second time. Because I ordered an SSD because the base model only has 256 gigabytes of storage, and I ordered like an NVMe that has a case and so on, and I want to install macOS on the SSD, so because it's even faster than the built-in one, and I'll have more storage, so I'll have to reinstall everything. So now I'm kind of like not installing too much because I'll need to do it later eventually again, but yeah, I'm waiting for that to arrive. They say run the code using this JSFido link, and notice that the console statement within display name function successfully displays the value of name variable, which is declared in its parent function. This is an example of lexical scoping, which describes how a parser resolves variable names when functions are nested. This word lexical refers to the fact that lexical scoping uses the location where a variable is declared within the source code to determine where that variable is available. Nested functions have access to variables declared in their outer scope. Right? Scoping with let and const. Wait. Closure, practical closures. Okay, scoping with let and const. They say traditionally before ES6, JavaScript variables, I think this ES6 is like before and after Christ. They always mention ES6. JavaScript variables only had two kinds of scopes, function scope and global scope. Variables declared with var are either function scoped or global scoped, depending on whether they are declared within a function or outside a function. This can be tricky because blocks with curly braces do not create scope. What do you mean now? Before Christ. You mean like you can both use... Wait. For people from other languages like C, Java, where blocks create scopes, the above code should throw an error on the console log line because we are outside the scope of the X. Okay. In either block. However, because blocks don't create scopes for var, the var statements here actually create a global variable. There is also a practical example introduced below that illustrates how this can cause actual bugs when combined with closures. So after Christ, JavaScript introduced the let and const decorations, which among other things like temporal, dead zones allow you to create block scoped variables. Reference error X is not defined, so they're using var here, but with const you cannot do it, and with let you cannot do it. In essence, blocks are finally treated as scopes in ES6, but only if you declare variables with let or const. In addition, ES6 introduced modules, which introduced another kind of scope. Closures are able to capture variables in all these scopes, which we'll introduce later. So we have closure now, and consider the following example. Oops, I did, and wait, fuck me, sorry. Alright, where is the following example? Cryptic out of context, welcome to the stream, brother, long time no seen, how are you? Welcome, welcome. So we have a function of make func, const name Mozilla, function display name that is inside console log the name, will be able to console log the name and then return display name. I came back for a short time, I have to work though. Yeah, right, we all have to work, so I fully understand you, brother, thank you for tuning in. Running this code has exactly the same effect as the previous example of the init function above. What's different and interesting is that the display name inner function is returned from outer function before being executed. So you will not console log the name because you're not executing the function. Wait, at first glance it might seem unintuitive that this code still works. In some programming languages, the local variables within a function exist for just the duration of that function's execution. Once make func finishes executing, you might expect that the name variable would no longer be accessible. However, because the code still works as expected, this is obviously not the case in JavaScript. So I'm working as I watch the stream. Hey, what are you working on? I have great trouble focusing like when I watch something. Advantages of HO. What is HO? Home office. Oh my god. Nice. If I watch something like when I'm working, I'm not really paying that much attention to the work. I can listen to podcasts if the work is repetitive. Finance as well, yeah, maybe, because I remember when I was home office and I was working for a call center, I used to like have the monitor of the call center interface, so on and so forth, and handle customer calls on one monitor, and on the other monitor I was playing Counter-Strike on my own computer. So one computer was the companies and the other monitors was hooked to my computer, and I was playing CS while speaking to customers. That's interesting indeed. Alright. The reason is that functions in JavaScript form closures. A closure is a combination of a function and lexical environment within which that function was declared. This environment consists of any variables that were in scope at the time the closure was created. In this case, myfunc is a reference to the inheritance of a function. Display name is then created when makefunc is run. Display name that is created when makefunc is run, okay, is a reference to the instance of the function. Display name, shit, I've already read that. The instance of display name maintains a reference to its lexical environment within which the variable name exists. For this reason, when myfunc is invoked, the variable name remains available for use and Mozilla is passed to console log. Here's a slightly more interesting example, a makeOther function. So function makeOther x, and you have a return function inside of that with y, which returns x plus y, which is basically what we had on the Odin project, but with a bit less code here, or a bit less naming. So you have const.5, which is make other 5, and const.10, which is make other with 10. So the first time it will make other 5, so x will be 5, and then make other 10, so the second time make other 10, the x will be 10. So once they console log it and do add 5, for example, on this function and pass in the 2, it will return 5 plus 2, 7, and on the other one it will return 12. I have a company laptop, but I use mine because it's faster and so on, but I still desire to place there. Yep, indeed. So, yo, what's up, bro? Hey there, S32, welcome to the stream. Quick question, do you know QBasic? No idea. I don't even know what QBasic is, my man, sorry. What games do you play EA on? I download Payday 2 just to see how it runs on the Mac, and it's pretty good. On my older computer I could barely run it. Alright. He knows QBasic. There you go. You find people that know QBasic. In this example, we have defined a function makeOtherX that takes a single argument x and returns a new function. The function it returns takes single argument y and returns the sum of x and y. Alright. In essence, makeOther is a function factory. It creates functions that can add a specific value to their argument. In the above example, the function factory creates 2 new functions, one that adds 5 to its argument and one that adds 10. This is very interesting when you look at it that way. Add 5 and add 10 both form closures. They share the same function body definition but store different lexical environments. In add 5's lexical environment, x is 5, while in the lexical environment for add 10, x is 10. Very interesting. What is QBasic, guys? You can tell me, I don't know. So practical closures are useful because they let you associate data, the lexical environment, with a function that operates on that data. This has obvious parallels to object-oriented programming, where objects allow you to associate data, the object's properties, with one or more methods. Consequently, you can use a closure anywhere that you might normally use an object with only a single method. Situations when you might want to do this are particularly common on the web. Much of the code written in front-end JavaScript is event-based. You define some behavior and then attach it to an event that is triggered by the user, such as a click or a key press. The code is attached as a callback, a single function that is executed in response to the event. So like mouse clicks, for example, on a button, we attach a callback event. Let's see. For instance, suppose we want to add buttons to a page and adjust the text size. One way of doing this is to specify the font size of the body element in pixels and then set the size of other elements on the page, such as headers, using a relative EM unit. Because those EM units will be relative to the body font size. So, such interactive text size buttons can change the font size property of the body element, and the adjustments are picked up by other elements on the page thanks to the relative units. Here's the JavaScript. So function make sizer size document, return function. So this function will have it's like a maker factory, so function factory they said, and this will be like 3 separate functions, and each of them will go through the body style font size and change the style in pixels. So size 12 will make a function that uses the size 12 for the body pixels, 14, 16, so on and so forth. These functions are now functions that resize the body to text 12, 14 and 16 pixels respectively. You can attach them to buttons as demonstrated in the following code example, so you can have different buttons for them. Alright. Supreme Overload QBasic Quick Beginners All-Purpose Symbolic Instruction Code is basically the first programming language taught to newbies in programming, but it's outdated, so it's been removed from the system. I studied it last semester in school. It helps you understand the basics of programming. Wow, that's really cool. Nice. Good job there. Coming through with the knowledge. Alright, so this was the last thing we needed to read from here. And let's see what's up with constructors. So what's wrong with constructors? 1 second. One of the key arguments against constructors, in fact the biggest argument, is how they look like regular JavaScript functions, even though they don't behave like regular functions. If you try to use a constructor functions without the new keyword, not only does your program fail to work, but also produces error messages that are hard to track down and understand. That's nice. In my university they throw us into C++ and good luck. But if you're interested in C++, I guess that's better, because even if you are interested in programming, like what are you going to do with QBasic? Except maybe you understand how programs work, but C++, if you're interested into that, I think it will be a great skill to know. You can make games and such. It's a very powerful language. At least it's not just regular C. That's even tougher. Alright. Yet another issue stems from the way the instance of works. It checks the presence of a constructor's prototype in an object's entire prototype chain, which does nothing to confirm if an object was made with that constructor, since constructor's prototype can even be reassigned after the creation of an object. While still seen in code, these problems led to the use of a pattern that was similar to constructors but addressed a ton of these problems: factory functions. Well, yeah, but I wanted to web dev, nothing to do with that. It was painful, almost failed at the class. Yeah, I would probably failed it too, to be honest. Good job on passing though. So factory functions, I didn't know about these. I didn't know these existed. I guess you could use just constructors and that's it, but you have factory functions. These fancy sounding functions work very similar to how constructors did, but with one key difference. They how do you say that word? Levy the power of closures. This like use the power of closures, I guess, or leverage. Instead of using the new keyword to create an object, the factory functions set up and return the new object when you call the function. You do not use the prototype. They do not use the prototype, which incurs a performance penalty, but as a general rule, this penalty isn't significant unless you're creating thousands of objects. Let's take a basic example to compare them to constructor functions. Yeah, same here in my country. For university you study C++ and Java, but I'm in high school and we deal with QBasic first. Nice. Do you guys like Skyrim? I think I do, but I've never played it. Maybe I can install it and maybe we can play it on stream sometime. I think it's really fun, but yeah, we'll see. Maybe I'll buy it and we can play some Skyrim. I should make like a gaming channel on the Discord. Do you guys agree? So we have const user function name, this dot name equals name, and this dot discord name equals add plus name. So this is like a constructor. Then this can be refactored into a factory. So we have const user equals function. This is function create user with a name. Const discord name, and then after that you return an object with name and discord name. That'll be fun. Yeah, indeed. We can maybe do that. I need to work on the Discord after that, so if you have any suggestions for the Discord, you can put it in this, the ideas channel to make use of it. And that's very similar, except it's just a function. We don't need a new keyword. Alright. This looks cleaner. Discord name. Can you still use like the objects dot and then Discord name, for example, to return its Discord name? Or yeah, I don't know. The object shorthand notation. Some might get confused by the way the returned object is written in the factory function. Example, in 2015, a shortcut to creating object was added to JavaScript. Say we wanted to create an object with name, age, and color. We would write it as follows. So const name, const age, and const color. Const.object is they're doing like a key value. However, now if we have a variable with the same name as that of the property to which we're assigning it, then we can write it once. So if the ones on the left and right side are the same, we can write them once. And because here we have name and Discord name, and those are the same, we don't have to write them as key value pairs. Another advantage to this is that it's now possible to console walk values neatly. If you want to have to walk these values earlier, you would have done the following. So name, age, color, which would result in a mess Bob25 red. Try wrapping it in some curly braces now, which makes it an object. Now it works as name, Bob, age 28, and color red. This is pretty neat indeed. We have destructuring. Yet another expression allows you to unpack or extract values from an object to array. This is known as destructuring. When you have an object, you can extract a property of an object into a variable of the same name or any named variables for an array. Take a look at the example below. Let's take a look at it because I didn't understand any of it. So you have an object A1, B2. Deconstructing is fun, but very, very useful. So let's read through it carefully then. We have const AB equals object. This creates two variables, A and B, which are equivalent to const A equals object dot A and const B equals object dot B. Const array 1, 2, 3, 4, 5, const 0, 0th u, first u equals array. This creates a 0, 0th u and first u, both of which point to the elements in this 0th and first indices of the array. The MDN documentation on destructing, deconstructing assignment has some great examples and should be a good read for this concept. Alright, so let's see indeed. We have let AB equal and rest. AB equals 10 and 20. Console walk A output is 10. Console walk B output is 20. Okay. And we have ab dot rest. I don't remember what the dot is. I have to console log rest expected output arrays 30, 40, 50. So the rest until those dots, I kind of remember that those are different variables that fill in the gaps, but I have to refresh my knowledge on this. So it will basically map A, B, and will make new, like, this rest will be mapped to these three. But that's not really an explanation. It's a very poor one if I did one. The object and array literal expressions provide an easy way to create ad hoc packages of data. So const x is an array from 1 to 5. The destructuring assignment uses similar syntax, but uses it on the left hand side of the assignment instead. It defines which values to unpack from the source variable. So we have const, alright, const y and z. So this will be the first ones from the x. Similarly, you can destruct objects on the left hand side of the assignment. So you can AB will be 1 and 2. No, it's A is object.a. Yeah, indeed. This capability is similar to feature present in languages such as Perl and Python. I guess let's watch a quick video. Let's go on YouTube and watch a quick video about that to see if we will be able to understand it better. So we have Destructuring JS. Destructuring in 100 seconds. Fireship 3 years ago, alright? Let's check this out.
The innovative.
Oops, sorry if that's too loud. Let me
Can grow smart.
Let me see if that's too loud actually. Maybe it's not.
You can grow fresh herbs and greens at home with zero effort.
I think about
The
that
smart
should be
garden takes
alright.
care of everything. Like
Destructuring assignment. Take values from arrays or properties from objects and set them as local variables. It's a technique that can make your JavaScript code more concise and readable. Imagine you have an array and you want to assign some of its values to local variables.
I'll play
One
it once again
option
because I didn't listen carefully.
Destructuring assignment. Take values from arrays or properties from objects and set them as local variables. It's a technique that can make your JavaScript code more concise and readable. Imagine you have an array and you want to assign some of its values to local variables. One option is to assign each variable by referencing its index in the array.
Alright.
That works fine, but it's not very elegant. With destructuring, we can do the same thing with a single line of code. By using brackets after const, we can assign a variable name to each index in the array. The position of the variable name matches the value's index in the.
Alright, what if you want to skip an index though? For example, you want to do the bacon and the fries, but you want to skip the pizza. How do you do that?
The syntax may look familiar to you if you've ever used React, which relies on destructuring for the useState hook. When working with arrays, you may want to omit a variable, which you can do by adding a comma without a variable name to skip that
sure.
index. In other cases, you might want to name the first couple variables, then put the remainder in their own array. That can be achieved by putting 3 dots in front of the variable name. You might also want to set a default value in case the value in the array is undefined. Use the equal sign to provide the fallback value. In addition to arrays, destructuring also applies to objects. Notice how we're duplicating the object's property name as a variable with dot notation. By putting braces after const, you can reference property names which will automatically become local variables, which is is much cleaner than referencing them line by line with dot notation. And just like arrays, you can use the equal sign to set a default value. But in some cases, you may want to use a different name than what's provided on the object itself. Adding a colon after the property name allows you to rename it, which is especially useful when dealing with name collisions, or when working with objects that use property names that are not valid variable names. In addition to renaming, you can also use a colon to access nested properties, or in other words, set a variable from an object within an object. In addition to destructuring top-level variables, you can also use the syntax in for loops, which is awesome when you have an array of objects. When working with functions, you can destructure arrays and objects passed as arguments, providing yet another way to obliterate unnecessary lines of JavaScript from your codebase. This has been Destructuring assignment in JavaScript in 100 seconds. Make sure to hit the like button, it really helps out these short videos. Thanks for watching,
Advanced
and if you want to
tricks.
learn more, hang out for a minute while we go
I
over
thought
a
this
few
was
more
longer
advanced
than
tricks that
100
you may not know
seconds.
about. One thing that array
Let's see.
destructuring enables is variable swapping without the need for an intermediate variable. It doesn't come up often in JavaScript, but it is a useful thing to know for computer science in general. Normally, to swap two variables, you need a temporary variable because once the first variable is reassigned, you lose its value. But with array destructuring, we have the syntax available to perform a swap without the need for the intermediate variable. Use destructuring to reassign the values by putting the original two in an array, but in reverse order. You'll probably almost never do that, but you might be able to use it to impress someone on a technical interview someday.
Yeah,
The other thing I
definitely.
wanted to show you is that destructuring can also be used with regular expressions. When you run the match function on a string, it returns an array of results. You can then easily provide descriptive variable names for the regular expression matches. That's cool, but I have one last thing to mention. Imagine you want to destructure an object, but you don't know the property name until runtime. You can use computed properties in destructuring just like you can with object literals. By wrapping a property name in brackets, it now takes a variable as its value instead of a static name. In other words, it's computed at runtime, which you can then follow with a colon to provide it with a static variable name to use in your code. And that's pretty much everything I know about
Alright.
destructuring.
Discover the new god.
Indeed, it is. It looks very useful. To be honest, I didn't understand most of it. I understood like 60% of that, and indeed looks like something very powerful and useful that we'll have to spend more time. So, indeed, I'll remember to check out this destructuring. So, private variables and functions. Now you may be thinking, where does closure come into all of this? Factories seem to be returning an object. This where we can extend our user factory to add a few more variables and introduce private ones. Take a look at this now. So function create user with the name, const discord name is add plus name, let reputation is 0, const get reputation which will return reputation, and const give reputation which will give +1 reputation. Okay. Hello, where are you from? Hi there, material developer, welcome to the stream, my brother. I'm from Bulgaria, thank you for tuning in. You regex. Aeon, I think you're a bit behind. Try to refresh the stream. Or you may not be, I don't know. I don't really understand them. Indeed. Alright, so this function create user will return name, discord name, get reputation. So it will first like return 0 and then return 1. Or it will not return anything, but you have I'll have these functions available for the user actually. So are you working currently or are you still going in as a software dev? I am working, but I'm not working as like a web developer. I'm working as a COBOL developer at a bank, and I want to actually move to my hometown, which I cannot do since I'm working for a bank as a COBOL developer, and I need to go to the office still sometimes, so I'm doing this transition in order to be able to work remotely or work from my city. Indeed, I was behind on the stream. Yep, same here. Alright, so const Josh create user with the name of Josh. Josh.give reputation, give reputation, and this will be in total of 2. So const walk discord name. And this is, wait, the whole thing is like one single function. Or no, it's, wait, return, alright, there is the return. But this function create user ends, where does that end? Yeah, there, because this is the return and this is the create user. So this outside of the functions. Are you good at maths? Not really, I wouldn't say so. And console discord name, George.discord name reputation, George.get reputation. So you have discord name and reputation of 2. Alright, private variables and functions. So those are, I guess the reputation is private and you cannot access, wait, I'm pretty sure you can do George.reputation. Can you do that? We've introduced a new metric for a new user, a reputation. Notice that the object we return in the factory function does not contain the reputation variable itself. Sure. So these are the variables and functions we have access to, and reputation is not in here. We have access to get reputation, which will then return the reputation, but to the actual variable we don't have access to, so we cannot do like George.reputation. Okay. Let's see. Nor any copy of its value. Instead, the return object contains 2 functions, one that's read the value of reputation variable and another that increases its value by 1. The reputation variable is what we call a private variable, since we cannot access the variable directly in the object instance. It can only be accessed via the closures we defined. So those are closures, they're saying. This is a closure and this is a closure. Okay. Concerning factory, I once tried to be good at maths. I failed. Indeed. I think I failed maybe in middle school to be trying to be good at maths. Sorry. Concerning factory functions, in elementary school I was the shit at maths, but middle school then it kind of all like went downhill. Considering factory functions, a private variable and function uses closures to create smaller dedicated variables and functions within a factory function itself. Things that do not need to return in the object itself. This way we can create neater code without polluting the returned object with unnecessary variables that we create while creating the object itself. Often you don't need every single function within a factory to be returned with the object or expose an internal variable. You can use them privately since the property of closures allow you to do so. In this case, we don't need to control the reputation variable itself. To avoid food guns like accidentally setting the reputation to minus so on, we expose the necessary details in the form of get reputation and give reputation. Alright, and we have prototypal inheritance with factories. We learned about this with constructors, but let's see with factories. In the lesson with constructors, we looked deeply into the concept of prototype and inheritance and how to give our objects access to properties of another with factory functions too. There are easy ways to do that. Take another hypothetical scenario into consideration. We need to extend the user factory into a player factory that needs to control some more metrics. Here are some ways we can do that. So function create player with name and level. To again have, this is like deconstructuring get reputation and give reputation equals create user name. Const increase level, shit. Create user. Where is that create user? So wait, we're actually, by doing this, we're doing like name.get reputation and name.give reputation, or is that right? I'm not sure. Const increase level, we have an arrow function with level post, and then we return name, get reputation, give reputation, and increase level. So we can return the name. We do not return the reputation or the level, but we can get a reputation, give reputation, and increase level. And I get it, but I wouldn't know how to explain it. Indeed. I don't know if I get it, but I surely cannot explain it. There you go, you can create a user, extract what you need from it, and re-return whatever you want to, hiding the rest as some private variables or functions. In case you want to extend it, you can also use object.assign method to add on properties you want. With object.assign, return object.assign user increase level. This is quite a bit to understand. I guess we will learn more about it in the assignments and additional resources, so I'm not going to worry about it too much. Where are we? The module pattern IIFEs. So in ECMAScript 6 introduced a new JavaScript feature called modules, which are a set of syntax for importing and exporting code between different JavaScript files. While they are important and powerful, they are covered a bit later in the curriculum. We're not talking about them in this scenario. Oftentimes you don't need a factory to produce multiple objects. Instead, you are using it to wrap sections of code together, hiding the variables and functions that you don't need elsewhere as private. This is easily achievable by wrapping your factory function in parentheses and immediately invoking it. This immediate function call is commonly referred as an immediately invoked function expression, or IIFE in short, or IIFE, immediately invoked function expression. This pattern of wrapping a factory function inside an IIFE is called module pattern. So we have calculator and function, const add, sub, multiplication and divide, and this probably we could have done it for the calculator, but I didn't know it back then. So he's making calculator dot add 35, it will return 8. That's very neat. In this example, we have a factory function creating some basic operations that we need only once. We can wrap it in parentheses and immediately call it by adding a parentheses, returning the result object that we store in calculator. So we immediately call it and wait. So we immediately call it with that function and we return all the constants, functions that we declared inside of it. And that's an IIFE. In this way, we can write code wrapping away things that we don't need as private variables and functions inside our factory function, and while they are tucked inside our module, we can use the returned variables and functions outside the factory as necessary. This then this seems like a really complex lesson, and I'm not understanding it fully by now, but we'll see. Encapsulating with the module pattern. At first glance, this does not seem particularly useful. If we have some code that we use only once, why not write it in the main section of our JavaScript file itself? After all, the power of factory functions lies in being, well, a factory function to make multiple objects, right? This is where we encounter the word encapsulation. So this is part of the object-oriented programming. Encapsulation, bundling data, code, or something into a single unit with selective access to the things inside the unit itself. While it sounds general, this is what happens when we wrap or encapsulate our code into modules. We don't expose everything to the body of our programs itself. Gargoman, it seems that work is going crazy. Look on the lecture. Thank you so much, Ion. Thank you for tuning in, my brother, and we'll see each other again very soon. Thank you for tuning in. Really appreciate you. Good luck at work. Alright. Take care, bro. See you soon. Yeah, take care. This encapsulation leads to an effect called namespacing. Namespacing is a technique that is used to avoid naming collisions in our programs. Take the calculator example into consideration. It is very easy to imagine a scenario when you can accidentally create multiple functions with the name add. What does add do? Does it add to numbers, strings? Does it take its input directly from the DOM and display the results? What would you name the functions that do these things? Instead, we can easily encapsulate them inside a module called calculator, which generates an object with that name, allowing us to explicitly call calculator.add.ab or calculator.sub.ab. Alright. We're kind of done with the reading, and we can go on to the assignments. We have Wes Bos has a beautiful and in-depth section on scopes and closures. Please check out these sections under module 3, the tricky bits. So let's open these and see what's up. The tricky bits. We have scope, closures. Wes Bos. Alright, so we'll read through this. This is all scope, yep. And then we go through the closures, that's fine. What else we have? We have the knowledge check, but we'll also go through these videos.
Hey, what?
This short 4-minute video. We have an interactive screen, 3 different kinds of prototypical inheritance with some good examples. Learning JavaScript design patterns by Adi Osman. Download ebook PDF. What are they saying? By Adi Osmani and Lydia Hallie. This leads us to patterns.dev, which... Wow. Single pattern, proxy pattern. Use a factory function in order to create object. That website seems very interesting, not going to lie. I might have to patterns.dev. Let me put it in the chat for you guys. Patterns.dev. Improve how you architect web apps. Oh, we can read online. This is the book. Alright, they have React patterns, vanilla patterns, view patterns. Nice. So maybe we can read on, introduction, singleton pattern, proxy pattern, prototype pattern. We can maybe read on that. Module pattern, let's see that. And let's see factory pattern. optimize your loading sequence, static import, dynamic import, bundle splitting, prefetch, preload. Nice. I think they have some pretty interesting stuff. Alright, but we're starting with the scope, and I'm just going to take a quick 10-minute break. 10-minute timer, and I'll be right back with you guys. So I'm taking a quick break, 10 minutes, and we'll be right back to continue with the learning. Thank you so much. Be right back. Alright, I'm back. Sorry for taking a bit too long. I just had something to eat. Right, is there a way to get rid of this? I don't think so for now, but it's fine. Let me open this chat on the other. Yeah, there you go. Okay, so we're doing scope. We have touched on scope a few times throughout this course already, because it's impossible to talk about variables without touching on scope, and there is no dark mode, but anyways. What is scope? Scope answers the question, where are my variables and functions available to me? Okay, so far in the course we have been making functions and variables, and they generally been available anywhere we wanted them. We have also seen some issues like when you create a variable inside of a function and they're not available outside the function. That is what scope is. Go to the playground folder and create a new file called scope.html, and use your HTML base inside of it. Add a script src to a file called scope.js, so on and so forth. Add a new scope. Alright, global variables. We'll start by talking about the first type of scope, which are referenced to as global variables. With global variables, whether you have a script tag or JavaScript file or run it in the console, anytime you declare a variable, it will be available anywhere in the application. For example, if you add a scope.js in the following code, const first name or first equals Wes, and then in the console type first, it will return the value of first. Also, if you were to add another script tag in the scope.html like below, will it work? Does that work? I say yes. Why does it work? Because when you just go ahead and create a variable in a JavaScript file, not inside of a function, inside of a module, inside of an if statement, when you create it out in the open, that is what is referred to as a global variable. You can access global variables from any other JavaScript that is running on the page, like a script tag or via the console. In the browser, the global scope is called the window. If you type window in the console, you see every single thing that is attached to the global scope is inside of the window. That is why sometimes you see people doing things like window.setTimeout. There's just also, it is also just regular old setTimeout. Both are the exact same thing. Methods that are globally available to us like setTimeout are actually on the window object, and that is what is called global. There is one thing to know about const and let. Let's say we added this code to scope.js, so we have const first, let second boss, and var age 100. If you reload scope.html in the browser and then the console type first, second age, you see the following values returned because they're all global variables. Okay, makes sense. However, if you type in window.first, window.second, you get undefined, but when you type window.age, it will return 100. This is because var variables are attached to the window object and they're globally scoped, and const and let are variables when declared, like the example above, are still globally scoped, they're just not attached to the window. That is not really all that important because you shouldn't be making global variables anyway. This is just to demonstrate why sometimes people write window dot or just type the global variable directly. The same thing goes with functions. If we make a function, function say hi console hi, we can call it with the following methods. So say hi, typing say hi in the console and typing window.say hi in the console. Why is it available at window.say hi? Because anything that is in the global scope is attached to the window object with the exception of const and let variables. Using global scope is almost never a good idea, but before we learn why that is, we need to learn about how different parts of scope work. So we have function scoping. Let's get rid of the script say hi code in the scope HTML, remove everything within scope.js and then add const h100. Create a function go and the following walk. So function go const here equals bond console walk h console walk here. So the h will be able to console walk it, but the here is inside the function scope, so we're not able to. And maybe that is because we not run the go function. We just defined it. Let's try running the go function so that the variable gets declared before console can go. If you refresh the page, we'll look at the console, we'll still get the same error. Why? This is the next type of scope, which is the function scope. What function scope is when variables are created inside of a function. Those variables are only ever available inside of that function. That means that anything we create inside the go function is not available outside of that function unless we were to explicitly return it and put it into its own variable when that function is run. If you modify the console walk here to be written with the go function, it will log. So function inside the go you console walk here. You can think of the curly brackets in functions as gates. They keep variables in and do not allow them to leak out. Now is the same for now is that the same for the opposite? If we were to console walk h from within go function, would that work? If variables can leak out, can they go in? If you refresh the page and look at the console, you see it work. This is an interesting thing about JavaScript and most programming languages. Variables, if they're not found inside of a function, they'll go up a level higher and look for a variable in that scope. If it's not available in that scope, it will go for a higher, for a level higher. We'll talk about multiple nested scope in just a second. So what is happening inside the go function? The code is saying there is no variable inside this function called h. So we'll go up one more level and look up. Now if we add it as the first line of go function const h 200 and refresh the page, is that going to error? It will be 200 because it will first take 200 and it will not go to look for another h which is 100. So it is allowed. It's 200 because it looks in the local function first and then does find a variable called h. However, if it's not found, it will go a level higher and look for it at that level. Why is this allowed? Why is it not breaking? If you ever hover over the variable in VS Code, you see you get an error in ESLint says h is already declared in the upper scope. That is what is referred to as shadow variables. You can name variables the same thing if they're not in the same scope. However, this is not a good idea because if you name a variable something that is the same as another scope, you limit yourself to being able to access that. Okay, sure, I get what they mean, but there may be really specific use cases where you need to do that. In the example above, if we wanted to access h100 from the go function, there is no way to do that because the variable has been shadowed, meaning it has been overwritten. A tip is that if you ever have a variable inside of a function that is very similar to a variable outside of a function, name the variable inside the function more specifically so you have access to both. In this case, inside of the function, you could declare a variable like const my h equals 200 instead of just calling it h. Okay. Oops, I clicked end again. Where are we? Box scoping. There's saying the next type of scope is box scope. We'll start by talking about var, let and const variables and how they're scoped differently. Const variables cannot be reassigned and let and var variables can be reassigned. They have a different way of how they're scoped. Let's do an example. Will the code below work? We already see that it's not working, but const equal true, const cool. So it's the const cool is inside of the if, so we're not going to be able to access it outside the if, and we're getting a reference error that it's not defined. What if we make it a var variable instead? It works. So vars are globally scoped, and even if we define it inside the if, we'll still be able to access it. If we define it as let, we'll still not be able to access it, and this is what happens. What is happening there is whatever you have a set of curly brackets, like in the if statement above, that is what is referenced to as a block. Blocks will be showing up in most places. The most common is probably in an if statement. We'll have lots more examples throughout this course. You can think of those brackets as gates. Those gates keep values in, okay? Anytime something is created inside of these gates, they are not allowed to leave the gates. If you need to access variables outside the gates that was originally created inside of the gates, you're not allowed to do so. There are a few solutions to that, because every now and then you run into a situation where you need a variable to be available outside of a block. What happens is you have to create the variable above it. We'll demonstrate it in this example. So let's see. Let cool, and then you reassign it inside of the if statement, but actually that you can console log it and it will show you true. Okay, in that example we have declared a variable cool without assigning anything to it. On the line that previously had let cool equals true, we do not declare the cool variable, we simply update it with cool equals true. What that does, it creates the variable in the higher scope. In this example it's a global variable, but if this was created inside of a function, it would be a function scoped. Then we update the variable and then it's available to us outside of the function. Here's another example that's a bit more realistic. We're getting into two different kinds of scopes. So function is cool name, let cool, if name equals Wes, cool equals true, so console cool, return cool. Alright, a bit more realistic scenario, he says. So what is going on here is that we have one scope, which is the function scope. One thing that can get confusing is that a function also has a block, so any let, var or const variables are automatically scoped to a function, because regardless if it's a function or a block, it's set of curly braces, so it's scoped into that. And then we have block scope, which is within the if name equals Wes. Again, to demonstrate, if we change the cool variable within the if statement to a const variable, like in this example, it would not work, right? Because we're trying to assign value to, let cool, const cool, return cool. What are they doing here? So let cool will be different from const cool if name equals Wes, const cool equals true. So console log cool and return cool. They're saying it will not work, but would throw any error. That's kind of interesting to me. Right, however, this example below does work. Let cool. Proud of you, man. Keep it up. Thank you so much, Tarek. Thanks for joining the stream. Really appreciate it, brother. You're making my day. We'll definitely keep it up. Although we went over how to access variables that are box scoped, in most cases that is not something you need to get fixed, and it's actually really nice to have box scope because you don't have variables leaking out of it. In the past we have had for loops such as the following, so console walk I, and that will walk from 0 to 9 as shown below. Sure, if you type I in the console it will return 10 because it will so it will go to 9 and then it will process y, 9 will be 10. We have this random variable that is outvoting called I, which should have been contained within the for loops, but because it's a var, it has leaked outside. By simply making it a let variable, that random I variable will no longer be voting because it will be scoped to the curly brackets. Box scoping is one of the reasons people say use const by default, let when you want to reassign it, and don't use var unless there is a specific use case for it. That seems pretty like good advice. To get back to our example earlier with isCool, we could have also solved it by changing the cool variable to a var as shown below. So yeah, like you already showed that. Why does that work? Because var is it's a var variable. Var variables are not block scoped. There are functions scoped. I thought they are globally scoped. That means they're available outside of the if statement block, but they're only available inside of isCool function. So indeed, now I remember that var variables are not globally scoped, but they are function scoped, so inside of their functions. Okay, and if they are declared outside of a function, then they are globally scoped. But I guess that is with let and const as well. Okay. We'll do another example of scope lookup to solidify that concept. Const doc equals sneakers function walk doc, console walk doc. So if we call that function, it will console walk sneakers indeed. We have another function go equals const doc sunny walk doc, and let's see what would that do before we read what's going on. Let's think about it. We're calling go, which will const the doc as sunny. Now we initially have const doc equals sneakers. That is like a global, and then we do a const inside of a function that is block scoped. We call go, and I'm just thinking if that will throw us an error or it will make another const doc that will be used to console log it. So I'm not sure in this example. We have a variable doc which is set to sneakers, right? We have a function walk doc. It will walk the doc variable. All right, so this is it. We have a go function that creates a variable named doc again, and it says the value of sunny. Then we run that walk doc function and we run go. When we call the walk doc function, is it going to walk sunny or sneakers? You may think to walk sunny because we declare the doc in the function scope. So when the function runs, it shouldn't look in its own scope for that. Or you might think that it may look sneakers because the function is declared within a scope, having doc variable inside of it, so it will look up for that variable. What does it do? It walks sneakers. Even though we run log doc function within the go function, and that function has locally scoped variable set to the value of sunny, it's still walking sneakers. And we have lexical and static scoping. So they'll explain why that is. That is because JavaScript has what is referred to as a lexical scoping or static scoping. Those are buzzwords in JavaScript. That means what that means is the way that variable lookup or scope lookup happens is where the functions are defined, not where they are run. So where they are defined and not where they are run. So this one doesn't have dog in it, so it will go to get dog is what I'm thinking. Although we const dog here, we're calling the function and it doesn't have any access to dog inside of it, so it will go up and find this one Snickers. At least this is what I'm thinking. So let's see. So even though the walk dog function is run inside of another function which has walker scope dog variable, it doesn't care about where it's run, it cares about where it's defined. Because walk dog is defined where it is, since it doesn't have a local variable named dog, it will just go up one level. So exactly what I said indeed. Ideally, the function walk dog would take a parameter of dog and then walk whatever parameter value it is passed, like so. Ideally, the function walk dog would take a parameter of dog. So let's say this way, walk dog with Rufus, it will console walk Rufus. Now that console walk will walk Rufus. Why? Because when a function takes in an argument, it will make local variables inside of that function named whatever you name the parameter, and then that's available to them. It is the same as doing the following: const dog whatever you passed in as the first argument to the function, console walk dog. Alright. Whatever you passed into the first function. This is what JavaScript is essentially doing behind the scenes. It is taking so they mean when you run it, this function becomes this on the backend, but we don't see that. This is what JavaScript is essentially doing behind the scenes. It is taking the value that you pass in, pass the first parameter and making it a local variable for the function. So go const dog sunny, walk dog with dog. The code doesn't care what you called the variable that you are passing it in, it just cares about the value. The example above is the same thing as just passing it a string of sunny as shown below. Okay, sure. We'll go over best practices and many more examples in this course. We have best practices. Try not to create global variables. It is fine for us to create them while doing these examples, and when we get into modules, it is almost impossible to create global variables unless you explicitly do something like window.imGlobal equals Wes. When we get into modules, unless you explicitly attach to the window with a module, it is very hard to create global variables, which is intentional. Functions are scoped the exact same as variables. You can create functions inside of other functions. We'll look at examples of why you might want to do that later. Here is an example in the meantime. So you say function inside of a function, and you say yo. If you were to write say hi Wes in the console, it will return Wes. Basically name to uppercase. So say hi Wes, it has defined function yell, so console name to uppercase, and it will yell, so it will invoke that function, and to go back to it, it will take the name from here and console it to uppercase, and that's why we'll get capital characters Wes. However, if you try to call the yell function outside of the say hi as shown below, it will throw an error. Alright, because yell, like we don't have access to the yell. Yell is inside this scope of the function say hi, and unless we call say hi, we don't have access to yell. And we most definitely cannot say just yell brackets outside of that function. What is happening there is just like variables, functions are scoped to the parent function. If you create a function inside of another function, that function will only ever be available inside of that. That is starting to open up what is referred to as a closure, which is a more advanced example we'll go over in the future. It is possible to do a function inside of a function, and we'll learn that in future lessons. So yeah, we have closures next. The future came in early this time, so just look at the closures. Just 1 second. All right. I don't know why, but the stream that I have opened on my computer also lags behind. I don't know if it's an issue with me or what is happening, but Closures is one of the scariest words in JavaScript, and a concept that comes up all the time in JavaScript, especially in interviews. Alright. What was it? Yeah. Make it a little bit bigger. Right, they're saying it's a hard concept to get, but it can be relatively simple to understand. We'll tackle now understanding of the basics of what a closure is. As we build stuff, Wes will mention when something is a closure to give us more context and examples of when closures are used. Create a new file closures.html in the playground directory and add our HTML base. Open up a set of script tags. Our examples will go within the script tags like so. Okay. A closure is the ability to access a parent level scope from a child scope even after the parent function has been terminated. Normally, Wes doesn't like examples that are not real world, but since this is a tough concept, we'll start with a simple example. We're going to make a function inside of a function called inner and outer to illustrate the concept, and then we'll get into more fun examples. Create a function outer, and within it set a variable outer var equal to here I am the outer var. Now inside of that, make another function called inner, and within it declare the following variable. So const inner var, here I am an inner var. In the previous lesson on scope, we learned that within the inner function we can add a log of the inner var variable like so. So they console log the inner var. You can also log the outer var within the inner method because of the scope lookup chain. Since there is no variable called outer var in that function, it will go a level up to the outer function, and since it finds that variable there, it will use that variable. So we have function outer, const outer var, here I am the outer var, and function inner, const inner var, here I am the inner var. Both you can console log the inner and the outer var, it's no problem inside of the inner function. Let's try calling inner from within outer and open the browser and console and run the outer function from the console. You should see both the inner and outer variables. Sure, the same thing would happen if you code it from within the HTML script like so. Okay, that makes sense. The inner function is able to do scope lookup and see the outer. We have already learned about that, and that's not really a closure. Now the kind of interesting thing, and that is where closures come into play, is where you don't call the inner function from within the outer function, but you call it at a later point in time. So let's not call it from the outer. Remove that line of the code where we're calling inner, and also remove the code to outer. From the outer function, let's return the inner function. You can return it two ways. The first way is shown below. So we return function inner and basically the same contents with the inner var and the two console logs. The second way is like so, function inner and then return inner, so exactly like that, but instead of calling it, we return it. And the first is just a bit more concise. So in order to have a closure, I think you have to return a function. We'll go with the second one, and after the outer function we'll add const inner fn equals outer. So after the outer function we'll add, so underneath here we'll have const inner fn equals outer. So I get why that is, because we call outer and we'll return inner from it. It will set the variable, so on and so forth, but what we return is that inner function. So we can const it as inner fn equals outer. There you go. Okay, what are we doing here? We're running the outer function. It is creating an outer variable, outer var. Then we're returning the inner function, which is why we're sticking it into a variable, inner fn. In the console, when we type inner fn, it will return the inner function like so. Okay, sure. The question is, if you were going to run inner fn right below the function expression, its outer var is still going to be accessible, or will it be undefined? So we know it will be accessible, right? So they run inner fn after that, and we run outer function on this line of code, which is where it created the variable and then it returned the inner function. Is that still going to be available to us, or it will be undefined? If you try that code, you see that they both work. What you can do is stick a function into a variable, and then at a later point in time you can have access to that function. A closure comes into play because you can access the function even though the outer function is done. We learned in scoping that when a function is done, anytime there are scoped variables that aren't returned from the function, they are not accessible. But we get this weird thing where we run the function outside of it and it's still able to access it. This is what is referred as a closure. JavaScript is able to create functions inside the functions, and it can still reach outside to the parent scope. Even though the outer function is done running, it will still maintain that variable in memory so that we can then access it at a later time. The variable is not cleaned up or garbage collected, which is a term that is often used. Why would that be helpful? It looks very confusing. So we have examples of closures. Let's look at some actual examples. First, we'll go over an example of a closure creating a function, which is what we just went over. The second example will be how you can use closures to create what are called private variables. Comment out the previous code and add the following. So we have function increase subscriber count. Thank you for notifying me. I haven't added the sub count because it would have taken a bit more time, but for the next stream I'll definitely add it. But nice, thank you guys, everyone who subscribed. Also, you can join the Discord and we're making a nice community there, so thank you so much whoever subscribed, appreciate you. So we have function create greeting and we're passing greeting equals nothing as argument. Okay, function create greeting, const my greet equals greeting dot to uppercase, return function with name, return my greet name. Okay, so they're saying this function takes in a greeting, the default of which is an empty string. this is how you make default. So if nothing is passed in as a greeting, it's an empty string, I guess. Assign it to the myGreet variable, which takes the greeting that got passed into the function, assigns to the myGreet greeting.toUppercase, okay, then returns to uppercase against it. From there we will return a function which we don't have to name, which will take in the person's name and return greeting. So why is this helpful? Why did we do this in two separate functions? So we're going to say hello, create greeting hello, say hi, create greeting hi. And then it's like a factory where we have different functions, and they say hello Wes, and it will say like hello Wes or hey Kate. That's pretty cool. Why did we do this? Because you can create functions that are based off of whatever greeting you like. Okay, if you refresh, you see the following closure. Okay, hello Kate. Yep. What is happening here is that when we create the outer function, create greeting, we had created a variable inside of that function, which is then accessed at a later scope, at a lower scope actually, sorry. We've got inner scope here. So this is the inner scope, and we have the outer scope here. Okay, so inner scope is everything inside that return function name, and the outer scope is like the outside stuff and like the whole thing. Since our inner scope references a variable that was created in our outer scope, that is what is referred to as closure. So this is what's referenced in the outer scope. We still are able to access our outer variables inside of the outer function scope, inside of our inner, even after the create greeting function has been closed over. That is the whole idea behind closures, it's being closed. That is the first example where you have functions inside the functions and they're able to access the closures data inside of that. Let me actually search for something because I'm interested if there is such video, closures, JS. Yeah. Alright, so I think we can watch this video because I think it will be really helpful. It's called JavaScript Visualized Closures, and this girl like makes really nice animations and explains concepts in a way that you can visualize it. She has only a couple of videos, but as you can see, like, it's very interactive, and I think we'll watch that video next. She has only a couple of videos, but as you can see, 78,000 subscribers with just 5 videos, which means this is really appreciated, and maybe I can do one of these as well, but we'll see on what. Okay, so I'll cue that next. So after we're done with private variables, so on and so forth, we'll watch this video. Okay. The other sort of similar way to create something called private variables, we'll demonstrate it in another example. We're going to create a function create game that will take the name of the game as a parameter. Inside of the function we'll declare a variable scope and another function win, within in which we'll increment the score and return a string with the name of the game and the score. Next, we'll create a variable hockey game and assign it to create game function, where we'll pass hockey as an argument and the following code. Okay. So we have function create game with game name, let's score 0, return function win equals, it will bump up the score, and return your name, game name, score is score, so your name hockey score is 1, for example. If you forget and notice that, wait, let's see what they need to say actually. If you forget to add the return keyword that is in front of win function when you try to run hockey game, so return function win, it will throw an error saying hockey game is not a function. Hockey game is not a function. Create game hockey. It will say hockey game is not a function. Now whenever we run the hockey game function, a message will be logged in the console showing the increment score. Your name hockey score is 1. What is happening there is the function that we create is called win, and we are using a score variable. So whenever we create a game, we create an empty score variable, and then the inner function, whether we actually run it, will increment the score variable that is of the outer scope. Why is that helpful? That allows us to maintain multiple games at once. Under the hockey game variable, we'll declare another variable like so, soccer game, create game soccer, and we can do this, we can do the following in the console. So we have different games. We have soccer, we have variables, and they each have their separate different scores. Even though the score variable is the same name, variable name, because we have created two separate win functions, by using the create game function, they each have their own private variable score. Currently, there is no way for us to access score. If you try to access it in the console, you get an error like the following: score is not defined. There is no way for us to access that unless we were to explicitly return that variable, or as we did in this example, by putting it into a string. To recap, closures are the ability of a child function or an inner function to access variables from a higher level scope even after the functions have been called or closed. Alright. Anyways, so let's see that video. Let's see if it's really that helpful. I think it will be. We have airplay, so on and so forth. Okay. I don't know if I do it full screen will take up too much of the screen real estate. I think it will. And if I do it like that, this is a little bit better. My camera is just a little too big. I'll make it a bit smaller. So let's do that while the video is running, and then I'll do it larger again. Okay. Safari, sure. Alright, let me put in the headphones and let's watch this video together on closures visualized. Wait, let me see how the volume is.
Developers, we often have to deal with closures, but have you ever wondered what they actually are behind the scenes? Well, in this video, I'll try to explain just that, but before you watch this one, I highly recommend that you also watch my previous video on execution context and environment records, because I'll just be assuming some basic knowledge in this video. The most important things I wanted you to remember from that video is that a new function execution context gets created whenever we invoke a function, and also a new function environment record. And I will not go into that much detail in this video, but long story short, environment records are used to manage the identifier bindings within a certain context. So the variables, parameters, function declarations, and so on. And during the creation phase of the execution context, memory space is allocated for all these values, and during the execution phase, the execution context is then pushed onto the call stack, and the code is executed. Now, after returning from a function, the execution context is removed from the call stack and is eventually garbage collected. Now, normally, so not talking about closures here, but normally it is only the function execution context that holds a reference to the function environment record. So when the function execution context has been garbage collected, there are no other references to this environment record, which is a sign for the garbage collector to then also collect that as garbage. It's also destroyed. So this means that we lose access to these variables, functions, everything within that environment record. But that makes sense because in this case, if outer has finished executing, we no longer have to use this count variable anywhere outside of outer. So it would just be a waste of memory to keep this around. However, it is possible to retain a reference to this function environment record, in which case it does not get garbage collected and we still get to use the variables within outer. And this happens, or the first step to make this happen is to have a nested function, for example, inner. So in that case, a new inner function object gets created, and function objects contain an internal environment property. And this holds a reference to the environment record in which they are defined, which in this case is the outer function environment record. So the inner function object's environment property is a reference to the outer function environment record. So now we have a reference between the inner function object and the outer function environment record. But just having this reference isn't enough, because now whenever outer finishes executing, there are no other references to the inner function object. So this also just gets garbage collected. We cannot reference it from anywhere within our code. And this then again leaves that environment record without any references. So this then also gets garbage collected. We show no mercy. So what we need to do is to retain a reference to the inner function object from outside of the outer function. So we need something like this, where we have a variable on, in this case, the global context, that references this function object. Well, luckily, this is pretty easy to do, because we can do this by returning this function object from the outer function and then assigning this value to a variable outside of the outer function. So let's return the inner function declaration from outer. So we're returning the inner declaration. We're not invoking it. And then we're assigning this value to the inner func variable on the global context. So now, whenever inner func gets initialized, outer gets invoked. And whenever outer finishes executing, the global inner func variable still holds a reference to the inner function object. And this inner function object in turn still references the outer environment record through its environment property. So this means that they will not get garbage collected, and even the outer environment record gets retained. It does not get destroyed, even though the outer execution context has been destroyed. And this combination of a function object with a retained environment record is called a closure. And the special thing here, or the special thing about closures, is that the environment record is from a function that has already finished executing, and the execution context has already been destroyed. So now let's see why this is actually useful. So now whenever we invoke inner func, which we can do because it's just invoking the inner function object, a new function execution context is created for inner, as well as a new function environment record. And environment records have an internal property called outer env, or outer environment. And this holds the value of the environment property of the function object for which the environment record is created. So in this case, the inner function object's environment property holds a reference to the outer environment record. So also the outer env, or outer environment property on the inner environment record holds a reference to the outer environment record. And the outer env property essentially creates a linked list, or a chain, the scope chain, of environment records. So whenever we try to access an identifier binding within a certain context, the engine first tries to find it within the current environment record. But when it cannot find it in the current one, it checks the environment record that is linked through the outer env property. So it's going down the scope chain. So in this case, within inner, we have an incremented count variable, but in here, we're also referencing count. There is no binding for count within the inner environment record, so it uses the environment record that outer env references, which in this case is the retained outer environment record. And this does have a binding for count. So because of that closure, we still get to use the count variable even though outer has already finished executing. To summarize what we just saw, so a closure is a combination of a function object and a retained environment record through its environment property. And then whenever we invoke this closure, this retained outer environment is part of the scope chain. So we still get to access all the variables from that function that has already finished executing. And closures happen whenever we have a nested function, and then we keep a reference to that inner nested function somewhere outside of that outer function. So I'm editing the video now, it's like 2 a.m., but I figured I'm gonna just add a little quiz to see how well I've explained closures. So pause this video and see if you know what gets logged whenever we execute this code. I'm gonna give you 1 second, but just pause the video and you'll have infinite time. So
Alright, so let's see. Function create counter, let count of 0. Function increment return post count and return increment. So we're returning that function. And we're doing const counter1 equal create counter, counter2 create counter. So these are two separate instances of the create counter function. And console counter1, console counter2, and counter1. So it will be 1, 1, 2.
Answer is 1, 1, 2, and let's see why. So what I wanted you to see here is that we're working with two closures. So I'll just start at the point where the global execution context has already been pushed onto the call stack, and we have the two uninitialized variables for counter1 and counter2, and also a function object for the create counter function. So now counter1 gets initialized by invoking create counter, and this creates a new function execution context also with a brand new function environment record. So just skipping to the execution phase, count is now initialized with the number 0, and then we eventually return the increment function from this function. So now counter1 holds a reference to this function object. So we have our first closure. And now the exact same thing happens for counter2. So a new function execution context is created with a brand new function environment record. Again, skipping to the execution phase, count now gets initialized with the number 0, and we can return the increment function. So now counter2 also holds a reference to this function object. It's also a closure, but notice how they both point to a different environment record through their environment property. So it's important to remember that that outer environment record that the closure points to gets created whenever we invoke this outer function, which we can do multiple times, in which case we create multiple closures. So now whenever we invoke counter1 for the first time, a new function execution context is created with a brand new function environment record whose outer env property is a reference to the first create counter environment record. So count is now incremented and 1 gets logged. Now whenever we invoke counter2 for the first time, the exact same thing happens, but now outer env references that second environment record. So that's still at 0, so count now gets incremented and 1 gets logged.
We have the alt, sorry guys.
So you kind of get the gist now, but whenever we invoke counter1 again, a new function execution context is created with a new function environment record whose outer env property is a reference to that first create counter environment record. So this was already at 1, so count is now incremented and 2 gets logged. And that's how we get 1, 1, 2. There are many use cases for closures, but they are excellent to retain state or context between function calls. And this can really help to optimize memory, but also reduce the amount of expensive function calls. So for example, here's a pretty common example with memoization. So inside the memoize function, we've got a cache variable that's just an empty object for now, but eventually we're going to store some results. We then return a function from the memoize function, so closure. So this means that we're just returning a function object that still holds a reference to the memoize environment record through its environment property. And we then assign this return function to a variable on the global context. So very similar to what we saw before, we now have a closure. So when invoking this return function, new execution context, new environment record, and this environment record then uses the memoize environment record as its outer env. And through this, we still have access to cache. So within the function, we check if the result has already been cached or not, in which case we just return the cached result. And otherwise, we invoke this expensive function. So in this case, we used a closure to kind of maintain a centralized cache between function calls. But it's also very possible to accidentally create a closure over large amounts of data, stale data, a large scope, and so on. So for example, here we have a function
So we have a function create user manager with the user ID. We have user data, const user data dot find, and you find the user with, or wait, find user with the user ID, return.
We have a user data variable where we fetch all the users. Now, if we're a little bit successful, this could be tens of thousands or even more users, just a really large object. And from this function, we return an object with a retrieve and an update function. They're arrow functions, but that doesn't matter. They're still just function objects whose environment property is a reference to the create user manager environment record. And this environment record has this large amount of data. So that's not great because we don't want to retain that in memory, especially not because we're not actually using any of this data in the returned functions. But because these function objects still hold a reference to the create user manager environment record, it is still in memory. So that's not great, and we might want to refactor that a little bit. Now, this is of course one very simple example, but what I want to show here is that it's very important to understand how functions interact with the surrounding environment records. So it can really help the performance of your app to sometimes check like, hey, do I have an accidental closure with large amounts of data, with a large scope, and so on. You might want to refactor that. I hope this video was at least a little bit useful and that you see that a closure is really just a function object with a reference to a retained environment property, which is then part of the scope whenever we invoke this closure.
Sure. That was a good video indeed, but I think it's for a bit more advanced people.
The event loop is...
I think we should have watched the execution contents video first, but... Ash has 4 videos and 1 short. Can you imagine that? Almost 80,000 subscribers with 4 videos. It's amazing, but yeah, I think this is... You must have a little bit more understanding than me, for example, to fully get it, but JavaScript closures. Alright, let's factory functions, so on and so forth. Let's just watch this one because it's quite short.
What's going on, everybody? It's your bro. Hope you're doing well. In this video, I'm going to explain closures in JavaScript. So sit back, relax, and enjoy the show.
Why is it private?
Alright, closures. A closure is a function with preserved data. It gives you access to an outer function scope from an inner function. This has 2 benefits. States of variables in the outer scope are saved, they're retained, and variables in the outer scope are considered private. They cannot be accessed outside of the outer function. Let's pretend that we're playing a game. We'll have a global variable named points, and I will set this equal to 0, as well as a function stored within a variable named score. Let score equal an anonymous function, and what we'll do is return points plus equals 1. So each time that we call our score function, we will increment our points by 1. Okay. So to call score, we would type the name of this variable, it contains a function, then to invoke it or activate it, we just add a set of parentheses afterwards. Then to display it, we just need to use console.log. So console.log, then invoke the score function, and this will return points plus equals 1. Then if I ever need to increment my points, I just invoke the function stored within score. If I was to invoke the function stored within score 3 times, my points would be at 3 then. However, there's one problem with this. Since points is a global variable, somebody writing malicious code can actually change this. So let's say that somebody's cheating and they will give themselves 100 points. So points plus equals 100. Well, now the user has 103 points because they cheated, they wrote some malicious code. So one way in which we can prevent this is to place our points variable within the function so that it's a local variable and no longer a global variable. So this is effectively private. You can't access this variable from outside of this function. If I attempt to increment points by 100, well then we'll run into a reference error. Points is not defined. So you cannot access points when it's a local variable from outside of that function in which it's contained. But now we have another problem. The value stored within points is not being saved. Every time that we invoke the function stored within score, we're effectively resetting our points back to 0, then incrementing it. So our output is 1, 1, 1 before it was 1, 2, 3. So one way in which we can save the data stored within a function is to create a closure. It's a function with preserved data. And here's how we can create that using what we have currently. So we will create an inner function. We will return an anonymous function. And within this inner function, what do we want to do? So let's take our points and increment it. So points plus equals 1. Then we will return our points. And then at the end, we will invoke this function by adding a set of parentheses to the outer function. So we have now created a closure. So not only is the value saved within our points variable, but we cannot access our points variable from outside of our function. It's effectively considered private.
Yes, material developer. I did HTML and CSS before that, but I know it from years ago when I first tried programming. But I went through the sections on the Odin project, which were quite in depth, and I don't think I streamed most of them because I thought of streaming after going through them, or I don't remember exactly when, but I did. It just, most of it isn't on stream. If you check the streams, actually like a week ago, I was going through intermediate HTML and CSS, so we went through that.
That adds a layer of security.
Also, day one was straight JavaScript. I think so, indeed.
Our program. So a key thing to remember.
I haven't streamed from day one. But yeah, I just guessed it would be better to start now, except like not stream at all, let's say. But yeah, you can argue that it's not actually day one. But we were pretty close. When I started, I didn't know like much of anything, so it was almost day one.
Things on the inside normally have access to things on the outside. Anything between this set of curly braces within our outer function is considered the lexical scope. Our inner function has access to this variable or anything else between this set of curly braces.
The parentheses right after the function, and that that invokes it.
That is considered the lexical scope, and we can save and preserve our points variable and not give anything outside of this function access to that variable. So that's kind of the point behind a closure. It's a function with preserved data. It gives you access to an outer function scope from an inner function. The benefits is that the state of variables in the outer scope are saved, and variables in the outer scope are also considered private.
Are you streaming on Twitch too? No, just on YouTube. I could start streaming on both, but I don't know how I'm going to have both of the chats open. I'm just not that advanced in streaming yet, but we can make it happen for sure.
You cannot normally access them from outside of the function.
I like
so
YouTube
that's
though.
a primer on closures. If you would like a copy of this code, I will post this to the comment section down below. But yeah, those are closures in JavaScript.
Perfect. Alright, we can close this out. You're saying there is an app that shows both chats on the screen, so there won't be any problems. Alright, I'll Google this for sure, and we can make this happen, because the more platforms, the more eyes you have on you, which is better. And we can get more people in the Discord, get a bigger community. With that being said, guys, thank you all for tuning in. I'm going to end the stream now because I don't have more time, but tomorrow we're going to continue. And I think I'm going to do a stream in the morning, but we'll see how that goes. Thank you all for tuning in. I really appreciate you. Exclamation point Discord to join our Discord community. We'll grow it together. And yeah, thank you for tuning in, and until next time, love you all. Bye bye.